for this first edition of this webinar series. For today, I want to talk a little bit about overcoming some scalability issues in Prometheus ecosystems. It's really about how to scale more and more workloads with Prometheus. And it's based on some learnings and some engagements with customers or interesting organizations in an open source project. My name is Jürgen. I work at a company called Dynatrace. That's also, let's say, an enterprise product and an enterprise competitor maybe to Prometheus. But I won't be talking here in this webinar about the Dynatrace product at all, because I will be talking about first some concepts, but also one open source project I'm heavily involved in, and that's called Keptn, and how Keptn can help you. But the whole first part of the presentation, I would say, is about more the concept. So you can just take these concepts and apply them yourselves. Or in the second part, I will be showing how we implemented this in an open source project that you can take already out of the box and that you can use. If you're interested into the project, I put on some links here, and I will also share the slides in the chat. So yeah, this is already my first slide here. What I want, so this is already kind of where do we what is the goal of this? What we usually want is we want to have some automated dashboards, because people tend to like dashboards. They like to take a look at the dashboards because they give them confidence what's really going on. It might be good, it might be not good to take a look at the dashboards. That's just a personal decision, I would say. If you have some alerting in the background, maybe you don't need the dashboards at all, but still you might want to have them in the beginnings of a project, or when you're onboarding more and more applications, so that you just have a confidence in what's really going on in your environment. And these dashboards, of course, you have to build. And building dashboards, for example, in Grafana, takes some time and just takes some work. So what you want to have is probably some automated dashboards for each and every new application or microservice or just workloads in general that you're putting or that you're monitoring with your Prometheus. You also want to have some automated dashboards based on some well-defined metrics. What you also want to have is automated alerts. So you don't want to think about writing alerting configuration for each and every microservice, but you want to have it maybe for a group of microservices, or to have like smart defaults of alerting. And you want to have, of course, as a basis, automated monitoring. So you want all your applications and services to be monitored and by Prometheus. So this is what we want. And the question is, how do we get there? In this presentation, I just start with very basic Kubernetes building blocks, because we will need them just to illustrate some of those challenges. And I will illustrate 3 challenges that we found when organizations were working with Keptn. And I've also blogged a little bit about this. So if you want to take it to blog, it's also a link here. It's not behind this Medium paywall. It's a friend link. So you are just you can just click on it, and it's not within this 5 stories that you're allowed to read. So it should be good if you're on the free or paid plan of Medium. Doesn't matter, with this link you should be able to read it. Yeah, so I will be talking about a couple of challenges, and at the end, or like halfway into the presentation, I will show you this open source project that was actually built for something different, but can also help you with this part. But there is more to it, and I will illustrate this a little bit. If you have any suggestions, if you have any questions, please just put them in the chat. Maybe during the presentation, I won't be very focused on the chat, but I will pick up those comments and suggestions after the presentation. And I'm happy also to discuss. Maybe you have some other challenges, or maybe you have some recommendations of tools that you are using. So I would be very interested in your stories. So let's get started with the main building blocks that we will be using throughout this, this short presentation. We have our application cluster, we have our microservices running in our pods, and they're exposing the metrics via their endpoints. And we might not only have one application cluster, but more application clusters. So that's kind of a given, and we can just assume everything's running in Kubernetes. It doesn't have to, but let's assume we just have some applications up and running, and it's more than one. Let's agree on this. And we also have Prometheus scraping all these metrics, and we have some Grafana using these metrics and putting like the dashboards on top of this. And we might also have more than one Prometheus cluster. But in this talk, I'm not focusing on this high availability setups of Prometheus. There are other projects, Tainus and Victoria metrics, that are two that just come to my mind. If you have more, also feel free to put it in the chat. But I won't be focusing on this technical aspect of high availability setups of Prometheus. I will be more focusing on this configuration aspect of Prometheus and Grafana. So the first challenge that we saw, Julius already showed you how all these different metric types work in Prometheus, and you will be using them in your PromQL. And you will writing some alerting rules based with this PromQLs. You might write some scrape jobs as well, and you might want to write some dashboard configurations for Grafana. So you'll write all this configuration, and then you apply it, of course, because you want to have it like applied, and you want to have it in your production environment. And what we have seen is that these configurations, they change over time. So what you do is, again, you take a look, where have I saved this configuration, you change this configuration, you apply it again. Sometimes it's maybe there are different teams that have access to Grafana, so they apply their own configurations. And then you take your configurations and apply them again. So maybe you're overriding the previous configuration. And it's a lot like the former times of, let's say, software engineering, where it was no mature versioning systems. But this is really a problem that we've seen, and you have to find a way to keep all this configuration in sync. And it's not only that you should be using Git, but actually more going into this direction of GitOps. The main idea is that the Git repository is the single source of truth. You put everything into this Git repository, and then you have an operator that will be synchronizing this Git repository with the actual, let's say, Kubernetes cluster or Prometheus configuration. So it's not that you're applying this directly, but you're just committing this to the Git repository. Maybe you have some pull request mechanism, and once it's in the master branch or in the production branch, you can even have different branches for your different environments, then it will be applied. So in this case, you always know what's really running in production, because no one is allowed to touch production anymore. So there are no changes in your production environment without putting them into the Git repository first, and you have all the benefits of Git that you might already love when you're a developer, and you have some centralized system that brings a lot of benefits. Then there is another part I was already mentioning. You have to write a lot of configurations, and these configurations, it's a lot of it is YAML or JSON, so it's already it's not two different languages. You can transform them from the one to the other mostly, but still you have to be confident in writing different writing dashboards is different than writing alertings with PromQL. So what we think is a great idea is that for writing all these configurations, make use of code generators. We found a couple of them, and we also saw that a lot of organizations, they write their own code generators. So you can feed them with some input data, and they will generate this configuration for you, which is really cool, because if you think about how often you have some issues in a YAML file because of white spaces or in JSON because of some brackets. So you can really limit all these errors by putting the input data in a code generator, and then the code generator will generate these files for you. And there are a couple of them. It's not only there is one, but there are a couple of them, and I've listed them in the reference section. And if you have more, if there is one code generator that you are using, then just let me know, and I'm happy to put this in the slides as well, so for others also to use them. Still, one part and one of the main challenges that we're also seeing is those code generators. They are built for different purposes. So maybe one code generator is especially for the dashboard, and the other one is especially for alerting. Maybe the one is based on some environment configurations. The other one is based maybe on some, let's say, site reliability practices, so that you have different concepts or different input data, how to feed them, and that might lead to one problem, that your configurations, they might a little bit drift out of sync after time. What do I mean with this? Imagine you have like one set of input data for one code generator, and you have a little bit of other input set for the other code generator. So the missing part, you cannot really make sure that the files that are generated from the one are actually have the same meaning as all the files that are generated from the other. So this can be, of course, can be taken care of manually, but still it's something that you have to be aware of. And what we think and what we have found in the keptn project is now that if you base all the input for the code generators on the same concepts and have basically all the code generators accepting the same input data, will eliminate this project. So abstracting a little bit more and focusing really on what you want to have instead of how you want to have it. And I think it's kind of a second iteration or third iteration of when you're starting with Prometheus and writing all your PromQL, and you're learning from all these different metric types. You have to write this, but if you can focus on what you actually want to have, and have all the code generators having the knowledge and writing all those PromQL for you, maybe not all of them, but like a same set of it, that would be great. So we try to define what you want to do instead of how it's actually done. And this was one of the ideas behind this open source framework called keptn. And I want to show you a little bit how to automate this configuration of Prometheus and Grafana with keptn. But it was actually built for automated quality gates for continuous delivery and automated operation. So it was kind of the vision of keptn, and the keptn main use cases are a little bit further down the road with continuous delivery and automated quality gates, where we use Prometheus data to check the service quality of a microservice that you want to deploy, and then give you a decision based on the quality and based on the give you a decision on the quality based on the metrics that we get from Prometheus. This was the actual idea. But since we needed a way how to query all this data in a, let's say, standardized way, we actually found that we can also automatically configure Prometheus and Grafana, because we have all the information already inside this framework. So how does it work? We basically have a couple of concepts in keptn, or a couple of parts that are already built in keptn. So we have our SRE-based concept that we call service level indicators and service level objectives. And it's only not invented by us, but it was actually, I'm not even sure if it was invented by Google, but some of the Google folks, they have written a book, and it's just called the SRE book. If you Google the SRE book, it will take you to one website. You can read it there for free. Basically, these concepts we're also using because they make a lot of sense in this context. And then we have this code generators as part of keptn. We have a Git repository as part of keptn, and we have a mechanism to sync all the changes from the Git repository to your Prometheus, to your Grafana, and to a lot of other tools that you might be using. So all these concepts are kind of baked in, but as said, if you don't want to use this open source framework I will be talking about, feel free to just think about the concepts I was mentioning, and maybe they can help you as well. So let me show you a little bit what how I can do a little bit of configuration with Keptn, and then I will show you and I will talk about what was really happening behind the scenes. So let me just stop this for a second and go into my Grafana. So what I did is I was just setting up a Grafana, and before the presentation I deleted all the dashboards I had, and was not a lot of them, but just a little bit. And I have a Keptn installation, and Keptn is a control plane that lives in my Kubernetes cluster, but I have a CLI and I can just query all the projects that I will be managing with Keptn. So in my case, I have one project, I have 3 projects, but I will be just touching one project. It's called SockShop. And what I can do is I can do the configuration. I can configure my monitoring system with Keptn. So I can just say Keptn configure monitoring. It will actually tell me that there are different options. So I have to provide a monitoring provider. And let's say it's now Keptn configure monitoring Prometheus, because I want to configure Prometheus. And it will just tell me I need a project, and the project is called SockShop. That's the one I just showed you. And the other part is a service, a microservice. And this one, in my case, it's the SockShop is a very simple web shop, and my service is called the cart service. It's a shopping cart service. I could also query it, but I already know it. So what I do is I will now configure this, and it will tell me a couple of things. So the first part is the Keptn context. That's, say, a technical implementation detail, but it will also tell me already no SLI found for production stage. No alerts created for this stage, but it was doing some parts successfully. So it was just that Keptn relies on these SLOs and SLIs, and just I put some SLOs and SLIs into the Keptn Git repository, but not for all the stages. So the service I'm managing here with Keptn is it has 3 stages: a dev, staging, and production. And I can put all the different files into all the different branches of the Git repository. So I can manage this configuration with the GitOps approach. So in this case, it was actually configuring a couple of things. Let us just reload the dashboards page here, and we see a Keptn dashboard. And we should see also some data already coming in here. And what we are seeing here is, for this project and for this microservice, I have now 3 very simple dashboards, but I have them in dev, in staging, and in production. So if only, let's say, interested in my production environment, I would keep it maybe like this. And I have the response time, the throughput, and the error rate already as an automated dashboard here. And this was already, let's say, from the built-in library of Keptn. So there is no need to know how to write all these, the PromQL behind the scenes. Keptn can already do it. If you want to have your completely own dashboards, you would just need to extend this Keptn service with your dashboard templates, and then it can create all these dashboards for you. So every time you have a new service, you might just want to add it to Keptn, and Keptn will create all these dashboards for you. And also behind the scenes, the scrape jobs for Prometheus were created, and the alerting rules were also created in Prometheus. And this is what I will be showing also to you. And therefore, I'm going back to the slides. So in one sentence, Keptn is an event-based control plane for continuous delivery and automated operations. So we are not even talking about configuration here, but it's one of the it's one part that you can do very easily with Keptn and with all the files and all the concepts that it provides. Sorry. And what does it mean to be a control plane? It's basically that Keptn has a built-in workflow for continuous delivery. So when you already built your container image, you want to ship it to production. And the way from, let's say, development to pre-prod to hardening to production, this way is a predefined and opinionated way in Keptn. And you can just plug in the tools that you want to use for this journey. So we have, for example, a Git repository, but you can plug in different Git providers like GitHub, Bitbucket, GitLab, whatever you're using. We have a service for deployments. Usually we use Helm charts, so we're using Helm for deployments, but if you have already your Jenkins pipelines for deployments, you can use this. We usually use JMeter for testing, but if you're using a different testing tool like Neoload, I think it's called, or Selenium or Blazemeter or whatever you're using, you can just plug it in and Keptn will trigger the tests. And then Keptn has its own validation service where it validates the quality of the service based on the monitoring data from Prometheus, for example. And then Keptn can promote it to the next stage and will be the same workflows in the next stage. So I've also here a slide with a little bit of the conceptual architecture. So again, we have this autonomous control plane and you have all the different services I was already mentioning for GitOps, the container registry with all the container images that you actually want to deploy, your tools for continuous delivery, the deployment tools themselves, let's say, like Jenkins, like Spinnaker, like XL Release, Helm, for example. You can connect testing tools. You can even connect notification tools or chat up tools. You can control Keptn with a Slack bot. So there was Citrix. They are using a lot of Slack bots internally, and they built an integration to Keptn where you can control Keptn via Slack and trigger deployments or trigger quality evaluations within Slack. And then you can connect Prometheus and Grafana for both the configuration part, but also during this continuous delivery to use all this data. So how is it actually possible or working that we are creating these dashboards, let's say automatically? It's not that it's out of the blue, but we are using some concepts. And as said, these are concepts from the site reliability engineering community. And we are using two concepts. There are 3 or 4 concepts, but we are basically using 2 of them prominently. And the first one are service level indicators. And we can think of this as a metric. So one example, it's also here on the slides, is just the error rate of login requests. That would be our metric. So it's the error rate of login requests. Here we don't talk about it, how we get this error rate, but it's just this error rate of login request is an SLI. And an SLO is defined upon those service level indicators. It's just a goal or an objective for this indicator. For example, the error rate of the login requests must be less than 2%, and we can even say within the last hour or 10 minutes. So we have a goal and we have one objective, and we can check if we are satisfying this objective or not. And we are using these 2 concepts, and we're taking these concepts and putting this into a file so it's human but also machine readable. For the service level indicators, I can already say that we have a couple of them already built in as a library in Keptn, so you don't have to write them by yourself, but you can always extend it. You can think of this as a library, and I will show you an example right here. So the indicators here is basically a file where you have on the left-hand side the name of the indicator that you want to use. On the right side, you have the PromQL. So you would think of this, okay, how do I actually now retrieve the error rate? And you can use placeholders so that it's easy reusable. If you know you have like 200 different microservices, then you would just the microservice name, for example, you would just use an and a placeholder. So you can just reuse this indicator file. And that's exactly what Keptn is doing, having some kind of reusable concept of those indicators, so we can build a library and we can already provide some indicators out of the box for you. And then we have the service level objective file, where you can actually now reuse all these indicators. So if you take a look, the error rate, we are using here the error rate, but we are not, it's not important how to actually query this metric, but we can just use it in our service level objective file, which makes it on the one hand very readable, and on the other hand also very tool independent. So if you're switching from one tool to the other, or if you want to gather some metrics directly from the JMeter result, then you can just use this metric here, and you don't even have to worry about how you actually retrieve it. So someone else might be responsible for this, or you're just using a library how to retrieve this. And you can then write your objectives based on this SLI. So for example, you just define a criteria. It has to be less or equal than 1, which means we expect a maximum error rate, or we accept actually a maximum error rate of 1%, or you can also have it in a relative way, something like it's only allowed to increase by maximum 2% to the previous run or to the previous runs. With runs, I mean evaluations. And you can combine it that it's an absolute and a relative threshold. You can do whatever you want, but it's just one file that is basically configuring. It's a quality description, it's a service level objective, but you can also use it for configuring Prometheus and Grafana, because you can also kind of take the inverse of the goals and define an alert on this. So when I was using the Keptn configure monitoring, it was basically sending from the CLI, sending this to my Keptn control plane, and then distributing it to the different integrations. And I had Grafana and Prometheus listening for these events. They were picking up these events, and then they were just executing or generating the YAML files and generating the JSON, and then applying this, sending it to the Grafana API. And by this, we're generating the dashboards and the alerting rules and the scrape jobs. So with this, we can, let's say, scale it, since it's just one and based on the same files for different services. So you can reuse these files, or you can just tweak these files a little bit for different kinds of services, and you can just apply them again. And with this, you can easily configure your fleet of microservices. And you can not only use this for the configuration part, but also you can use it for checking the actual quality. And we call this the Keptn quality gates. We are using here on the left-hand side the exact same files, but for like the use case we are using these files is now a little bit different. So in the first part, we have configured our Prometheus and Grafana. In this part, we are actually using this configuration, using all the data that's coming from Prometheus by doing an evaluation of the quality of a service. So let's say we are evaluating in the last 30 minutes a specific microservice based on these two files. And what Keptn will do is it will reach out to Prometheus, will gather all the metrics, will then score the metrics based on this objective file, and will come up with a score for each and every SLI, and will calculate a total score. And we should also see the total score somewhere here. Here you go. And with this total score, it will take a look, is the total score above a threshold or below a threshold, and will give you basically a thumbs up or a thumbs down. You will get the whole result, so it doesn't really matter if Keptn tells you if it's a pass or a fail. You can interpret it also in your way, but you already get the indicator. Is this quality evaluation, is it good or is it not good? And with this, you can use it in either in a CD pipeline to roll back or to promote, or you can just use it for your developers so that they can just trigger and ask about the quality evaluation of their microservice that they just deployed to a testing environment. So how can you actually use it from its very beginning to configuring the monitoring solution to using the data of the monitoring solution. First, you have to install Keptn, of course. It's basically a two-part installation, let's say. You will download the Keptn CLI to your local machine, and from there you just type Keptn install, and it will connect to the Kubernetes cluster, or will ask you for a Kubernetes cluster, and will then install the Keptn control plane in this Kubernetes cluster. If you don't want to use Kubernetes, there are also some other distributions available, like K3S, which is a very small Kubernetes distribution, and you can just run it on a VM, and that's totally fine. So you will install it, and then in the first part you will create a project, and this project is based on a shipyard file, and this shipyard file is already indicating how many stages you have, like a dev, pre-prod, and production stage, which deployment strategy, which testing strategy you want to apply. And so this shipyard file really defines what you want to have. There is another concept, it's called the Keptn's uniform, and in this you define the tool set, what you want to use. Do you want to use Grafana? Do you want to use Prometheus? Do you want to use GitHub or GitLab? Do you want to use Blazemeter or JMeter? So these parts are also defined in a separate concept. But you can just use the shipyard file, and you will create this project, and Keptn will set up its internal Git repository, and will also, if you're using it on a Kubernetes cluster and you want to also do the deployments with Keptn, then it will also set up the namespaces already where all the different stages of your shipyard file go. In the next part, you will onboard the services like the shopping cart, and with all those Helm charts. So you just use your Helm charts and give it to Keptn, so Keptn can manage them for you. And Keptn will just take these Helm charts, store it in the Git repository. You will also add your SLI and SLO files that can be then used for the configuration. You will do the monitoring configuration. So a couple of steps, like all the previous steps, you only do it once. Also this step, you only do it once per service. And some other parts like deployments, you can do multiple times, but it's a lot of like one-time needed configuration. So in this case, you will just use the files that you already added, and then you are deploying with Keptn. And the story of deploying in Keptn is very simple. It's always, doesn't really matter how many stages you have defined your shipyard, if you have dev, pre-prod, and prod, or if you have dev, pre-prod, hardening, pre-prod 2, security, and production. It doesn't really matter. It's always the same workflow. It's always first the deployment, then the test execution. Next step is the scoring. That means the evaluation. Keptn will gather all the data for the exact time frame of the tests. Since Keptn is a control plane, we'll know when the tests have been started and the tests have been finished. So we'll gather the data for this time frame. We'll calculate the score, and we'll promote it to the next stage or roll it back. And if it's promoted to the next stage, it's again the same workflow. It will be first deployed. All the deployment information, everything that's going on is stored in the Git repository. So basically everything is GitOps based. If there are no tests, for example, in production, you might want to execute tests. It's like there is a slot for, let's call it a slot, but there would be some test execution, but if there's no test execution, we just skip this part. We can still wait for a couple of minutes, for example, because you have your end users in production environment. They will click around, do the testing, more or less do the testing for you. They are using your software. So with this, it will then do another scoring and will decide if it should be promoted or not to the next stage. So it's always the same workflow, kind of based on the same concepts. So how did we do this integration of Prometheus and Grafana into Keptn? The Keptn control plane itself has no knowledge of any tools, let's say. So it is not part of the Keptn core product. So we don't want to be a Prometheus tool, but neither we don't want to be a Dynatrace tool. So we decided not to put any hardcore any hard dependencies on external tools like the monitoring into keptn. So they live in our keptn config repository, or actually organization, and you can just fetch them and install it next to your keptn installation. And we have the Prometheus as a Prometheus service, which is responsible for configuring Prometheus. If you don't want to configure Prometheus, but just use Prometheus as the data store for keptn, you can just use the pre-Prometheus SLI service, which queries all the data. And of course, then we have the Grafana service, which can configure your Grafana dashboards. Well, so all the links that I've been mentioning earlier for all the code generators, I also put here. You will find a couple of links also early in the presentation. Again, here a link to the blog. If you're thinking that keptn might be something that's useful for you, you can check it out. It's keptn.sh. That's our website. And we also, we have a community page if you want to contribute to keptn. And actually, yesterday, I think, the Hacktober Fest was announced. It was announced by, I think, by DigitalOcean. keptn is also not affiliated with DigitalOcean, but if you're contributing to open source software during the month of October, you will you can receive, I think, a free T-shirt or something. So if you think you want to contribute to open source, I think Prometheus or keptn are two great projects. So if you want to contribute, please go ahead. And if you want to get a free T-shirt, you would have to do this via hacktoberfest.com probably. But just check it out if you're interested in contributing. And I think, yeah, if you're interested in the updates, I put all the links here. And I'm happy to answer some questions or start into a discussion. Either way is fine. So thank you so much. And I'll open the chat here.